All right, so let's talk about the flood, and if in fact there was a flood. Oh, before I go any further, let me just stop and say, are there any questions about kind of the overview that we talked about so far? Anybody got any questions? Clear as mud, huh? All right, so it's just remarkable.
Clear as mud.
Yeah, so it's really remarkable when you think about the Earth being covered in water. In fact, it is a water planet. So you know, when you look at the Earth in the solar system, and not only the solar system, but in the entire universe, as far as we can see, as far as we know, scientists, researchers, explorers have not been able to find a planet that actually has water on it. And not only do we have a little water, we have a lot of water. And it covers the majority of the surface of the Earth. And the question is, was there a flood? The Bible talks about a great catastrophic flood that happened at the beginning of time. And if we're going to talk about the archaeological record, we've got to talk about the flood, and if in fact there was a flood. Let me just say, before we sort of get into some of the evidences, something that I think is very important to keep in mind. This is just a general observation about just the facts of our Earth and where we are in the solar system. As you can see there from this photograph, and I wish in fact, I need to include this other photograph from Carl Sagan. Well, actually, Carl Sagan didn't take it. It was taken by Voyager spacecraft. Do you remember that photograph that Carl Sagan actually wrote a book? It's called The Pale Blue Dot. You guys remember that? It's a photograph showing the sun as a little tiny blue speck in a beam of sunlight. And it's just like a tiny speck. And I need to have that photograph in the next presentation I give. But it's really, really revealing, and it shows you the vulnerability of the Earth. The Earth is vulnerable. I mean, we are susceptible to anything. I mean, meteorites have hit, and we have evidence of this. We see evidence of this all around the world. So it's an open system, is what I'm trying to say, is that the idea of a global catastrophe is not just on the surface. Even if you didn't know the Bible, it's not crazy. It's very plausible that some major catastrophic event happened in the Earth's history. And I think as we begin to unpack this, I think it actually makes a lot of sense when you look at all the data, when you look at all the information. Again, this is not from archaeology, this is from geology. This is from earth science. So, local or global. There are strengths and weaknesses to both views. The view that I'm going to be arguing tonight is the global flood. And so the name of the game for global flood is something that, is sort of a term that was coined by, I think, flood geologist, catastrophic plate tectonics. So you guys may already be familiar with the theory of plate tectonics. Essentially, the Earth, let me go back to picture the Earth. The surface of the Earth is like a giant orange, and the the outer lithosphere is like that thin layer of orange peel. The majority of the Earth is under the crust, and that crust, that orange peel, if you will, can move around, and it has. And we see this all throughout the Earth. We see this under the oceans, which is a little bit thinner than on the surface of the Earth, and we see this all around the world. So the question is, what is catastrophic plate tectonics? Essentially, it is the argument that I'm going to present is essentially almost identical to what modern geology says is the history of the Earth. It's just sped up a lot quicker. So I follow the mainline view of plate tectonics, that the Earth, the continents were joined together at one time. There was a supercontinent, Pangea, some form of supercontinent. They were joined together. We can see this geologically, but they rapidly spread apart. Now, in typical geological plate tectonics, this happened over a period of millions and millions of years. This slow spread continental drift, they call it. And these continents are splitting apart. But catastrophic plate tectonics is the view that these continents split apart very rapidly. In fact, within the period of a year. And there's really good geological evidence that this is actually the case. And in fact, there are what's called cratonic megasequences that are found around the world. What in the world is a cratonic megasequence? Again, my computer's freezing up, so there we go. So a cratonic megasequence is a very large scale lithostratigraphic, big word, it just means basically rock layer sequence, lithostratigraphic sequence, that a complete marine transgressive recessive cycle called a craton. They're also known as megasequences or stratigraphic sequences or slough sequence or supersequence or simply sequences. Again, this is all in the modern geological literature, these cratonic megasequences. What they are basically is geological evidence of sea level rising and then receding, thereby depositing layers of sediment onto an area of ancient rock called a craton. Places such as the Grand Canyon are a good visual example of this, apparent in the layers deposited over time. In the Grand Canyon, all of the mega sequences are visible in the canyon. So basically, if there was a global flood, then you're going to expect to find these major sequences of rock that are laid across the entire world. And that's exactly what we find in these mega sequences. So this is a cross-section of the Grand Canyon. I'm not saying the Grand Canyon is caused by the flood. What I'm saying is that in the Grand Canyon, you can see on the walls these 6 mega sequences that are laid down all the way down to bedrock. So the very, very foundations of North America are found in what's called the Zoroastrian granite. So in the Grand Canyon, you can go down and you can actually see the very bedrock of North America found in the lower layers of the Grand Canyon. So what are the mega sequences? Here they are. This is the Sauk, the Tippecanoe, the Kaskaskia, the Absaroka, the Zuni, the Tejas. I think that's it. And so basically the Sauk would be the earliest flood deposits. And then the second, so it was the waters rising up and lifting up all the sediment and then depositing the sediment and then receding back. Because you got to remember, the flood was a year-long event. You've got the breaking up of the fountains of the deep in which the waters rose up, and then you've got the waters receding back. And so that's the names that they're given by the geologists today. You can actually look this up. These are all actually on Wikipedia if you want to look these up. These 6 cratonic mega sequences that are found literally around the world. You can find these around the world. This is a map of the extent across North America of 2 of those, or 2 sections of those layers, the Coconino Sandstone and the DePete Sandstone. These are found one on top of the other. So some major event basically deposited all of this sand across North America, and it goes all the way up into Canada. And in fact, you can see this map here in the Grand Canyon covers 200,000 square miles, including the Grand Canyon, and it extends all the way out there. This shows you the extent of this layer, and it's found around the world. The sandstone lithosome includes DePete's formation in the Grand Canyon. So that means that this layer of rock was deposited first, and then it was cut through by some force after the flood in the Grand Canyon. So the thing about the Grand Canyon in geology is that it's not that the geologists are saying, flood geologists are saying that the cutting of the canyon. Think of a chocolate cake or a cake. You got the horizontal layers of the cake, the horizontal layers, and then you get a knife and you cut down those layers. Well, the Grand Canyon is a cutting across of those horizontal layers that were laid across, and they must have been rapidly deposited because of some of the geological sequences or features that we see in those. And this is a National Geographic diagram of North America during the Middle Devonian, they call it. Essentially, they're basically saying that the majority of the United States was actually covered under a shallow ocean. And I would say even more than that. So what are the geological expectations of a global flood if there was a flood? You would expect to find these things: fossil sea creatures high above sea level, rapid burial and sedimentation of fossils in coal beds and other deposits, rapidly deposited sediment layers spread across vast geographical areas, sediment transported long distances. You'd also see rapid or no erosion between strata. You'd also expect to find strata laid down in rapid succession. In fact, it's exactly what we find in the geological record. In the Grand Canyon, again, this is those horizontal layers. What you see in the bottom there is something called a cross-bedded sediment. So this layer on the bottom, it was basically like a sand dune. Sand was going up and it was forming like a sand, like it would go over like round. And the layer on top cross-bedded it. In other words, it cut it off rapidly. And you notice there is a definite, in that where the finger is pointing right there, there is a definite boundary between the crossbed and the layer on top, which means that it must have been laid down in very rapid succession, not over a period of millions of years. If this was laid down over a period of millions of years, in that boundary, what we'd expect to find is what's called chemical erosion. We don't see it at all. This is an event that happened very, very rapidly. So this is the cross-bedded section of that. And another very mysterious section of the Grand Canyon, not only that, in the Grand Canyon, but it's also across North America, is called the Great Unconformity. Again, according to traditional dating, not even in creation dating or anything like that, according to traditional dating, there is a billion, with a B, a billion years of time missing in between the Docks Formation below and the Tapete Sandstone above. And my friend there, Ting, is a professor of Greek out in San Francisco at Golden Gate Seminary. He's got his hand literally on the Great Unconformity in the Grand Canyon. And so, yeah, it's a problem for your typical understanding of geology. Also, we have in the Grand Canyon the folding in the tapetes, which means that these layers must have been soft when they were folded. And we see this in the tapetes. Also, we see it around the world as well. Now, let me just pause here, go a little bit of a rabbit trail. There is a bias in geology against catastrophic processes that affect Earth's history. That actually goes all the way back to Charles Darwin and the influence of Darwin's book on the origin of species. Now, Darwin relied very heavily on the geology of Charles Lyell. And if you know anything about Lyell, Charles Lyellian geology, basically it's a theory called uniformitarianism, which basically says that the present is the key to the past. So in other words, if you want to understand the present geological formations that you see, then you have to rely on what you see happening today, uniformitarian. In other words, things are remaining the same. And before that, there was a view of geology called catastrophism. And there was, in the 1920s, there was a very famous episode in American geology where this bias against catastrophism was really a black eye in the history of the modern American geological community. So Harlan Bretz was a geologist working up in the Pacific Northwest and primarily Washington State, in the scablands of Washington State. And what he wanted to do was to try to explain the Western Badlands of Eastern Badlands of Washington State. And basically what he showed was that this was the result of a catastrophic flood, but it was a local. There was a glacier just north, and there's a glacial dam. In other words, as the glacier began to melt, that formed a big lake inside the glacier, and the edge of that glacier burst, and all those millions of tons of water came rushing out and carved the entire eastern scablands of Washington State in a matter of hours. So this is a photograph of the glacial Lake Missoula flood. The scab lands that are there, the gray there, it's in eastern Washington state. This is where the proposed ice cork was. But when he published this in 1920s, this was at the height of the whole Scopes monkey trial, you know, and Darwinism and all that. And now get this now, Brett was not a Christian creationist. He was not trying to prove Noah's flood. He was trying to show that the eastern scablands were a result of some major catastrophe. It was a local thing, again, formed by a glacial lake that burst, but it did show that you can have geological formations that form in a matter of hours and days and not millions of years. So this is really kind of a black eye on the scablands. They're basically cover 15,000 square miles in Washington state. You've got Palouse Falls, and you see there on this photograph, it sort of does look like the Grand Canyon, doesn't it? And it was formed in a matter of hours, again, or 1 to 2 days, not millions of years. So this just is a good example to show that you can expand that out on a global scale, and you can explain a lot by the global flood. This makes more sense. This is a quote here from Stephen Jay Gould at Harvard University. Brett stood against a firm, highly restrictive dogma that never had made any sense. The emperor had been naked for a century. Charles Lyell, the godfather of geological gradualism, had pulled a fast one in establishing the doctrine of imperceptible change. And then he says this: the establishment, as represented by the United States Geological Society, closed ranks in opposition. Instead of protesting Brett's flood on its own merits, they rejected it on general principles. And so, actually, I got another quote. It's not on here, but basically, what Gould says is that Lyell won with rhetoric what he could not win with data. So basically, they rejected the Brett's flood based on the fact that it sounded too much like Noah's flood, so they rejected it. He ended up being vindicated years later. So he was vindicated. Brett's was.